Welcome to Math 1324. This is section 6.1. Alright, in question 1 here, we want to find a solution of this particular system that they've given us. And they've told us that x1 is 0 and s1 is also 0. Well, what does that mean? Well, let's see. If x1 is 0, that's missing. S1 is 0, that's missing. And so we get 6x2 is 36. Divide both sides by 6, and so we figure out that x2 is 6. So that can lead us to the next problem. So let's see, this one is 0, that's gone. 5x2, all right, let's see, that's 5 times 6, we just found x2. So 5 times 6 plus s2 is 38. So 30 plus s2 is 38, and we can solve and figure out that s2 is 8. All right, so that gives us our basic solution. Now we have the same kind of deal here in question 2. We are now given x2 is 0, s2 is 0. So let's see, x2, that would be gone. Doesn't help because I still have x1 and s1. Let's see. Come to this one, x2 is 0, s2 is 0. That's good. That gives me that x1 is 7. And so now I can come back to this first one now that I know x1. All right, so 7 times 7 plus s1 is 45. 7 times 7 is 49, and so I get s1 is negative 4. So working our way through the pieces we have and the pieces that we need to figure out. All right, in question 3, we get to the thing that we really want to start to solve. We want to maximize something, this particular relationship, subject to these conditions. Now we already have seen that these last two mean that the problem is in quadrant 1. These are two lines, and we're going to get a feasible region. Now how do we do that? Well, we take each one of these and we introduce something called a slack variable. Now what this slack variable does is the following. We have 2x1 plus 3x2. This is less than or equal to 12, so it's smaller. So if it's smaller, if I add something to this, I should be able to bring the amount up to 12. And that's what this first slack variable does. Now there's no guarantee that that amount would bring the second one up as well. So it gets another different slack variable, s2. And so this is what we do to bring them up to being equal. And again, they're called slack variables. All right, what about question 4 here? We have a constraint, a thing we'd like to maximize, subject to these conditions. All right, this says it's in quadrant 1. Only one item here, so only one slack variable. So 8x1 plus 3x2 plus our amount to bring it up to 16. All right, in question 5, well, they are giving us this system that has some slack variables. And they have all these different solutions to this particular problems. Now, we're looking at basic solution B. So here's B. So don't get confused. A, B, C, D, E, F. These are the various solutions, we're looking just at solution B. What are the basic variables? Well, the basic variables are the ones that are not 0. So the basic variables are x2 and s2. All right, in question 6, we have 3 slack variables, 3 sets of equations. They've listed for us all the basic solutions. We're interested in G, just in G. So we need to figure out what is x1, s1, s2, given that x2 and s3 are 0. All right, so let's see what happens. If x2 is 0, all right, s3 is 0. All right, S3 would be right there. All right, so what does that mean? So here we have all the 3 problems. Here's where the S3 was 0. Here's where the X2 was 0. So how do I solve something like this? Well, let's see. From this last equation, I get 4x1 is 40. Divide both sides by 4, and so I get x1 is 10. So now if I plug that in up here, 10, I can figure out what s1 is. And that would give me that s1 is 18. Now what's missing? Let's see. I've got x2, I've got s3, x1, S1. I'm missing S2. So what do I know? Where's S2? Right here. I now know X1 is 10. I know X2 is 0. So put all that together and I figure out that S2 is 10. Again, using the pieces that we have to try to figure out the pieces that are unknown. All right, so let's see. Similarly here, 3 equations. Got them. We're interested in I. All right. So what are we given? Well, S1 is 0, S3 is 0. All right, so I'm looking at all that. S1, 0, S3, 0. All right, so it looks like I can deal with these first 2 equations and figure out x1 and x2. So I'm going to eliminate x1 by multiplying the first equation all the way through by -3, add them up, and I can figure out that x2 is 21. Well, if x2 is 21, s1 was 0, I now can figure out that x1 is 8. All right, so what's missing here? Let's see. We know x1, x2, s1, s3. I'm missing s2. So come to the equation with s2. Plug in x1 is 8, x2 is 21. All right, did that right there. And so now I can figure out that S2 is -1. All right, so let's see. We're going to convert using slack variables and then construct a table of all the possible answers. Well, let's see. There's only one inequality, so one slack variable. All right, now how do we make this table? Well, I list x1, x2, s1. All right, they're all listed here. Now, what I do is I set 2 of the 3 to be 0. And I look at all the ways to do that. So I could have x1 and x2 0, leaving s1 to be free. So, and if that's the case, I get s1 is 12. I could have x2 and s1 be 0. All right. This is 0, this is 0, so solve that x1 is 4. Now the only other possibility is if x1 is 0 and s1 is 0. All right, this is 0, this is 0. So for x2, I get that that's equal to 3. Now, what's this feasible business? Well, feasible means that each of the items is greater than or equal to 0. The s's have to be 0. Remember, we're trying to add something to bring it up to a certain amount. All right, what about this one? Question 9. We have two equations. All right, two inequalities. I'm going to need two slack variables. All right, two slack variables. We've listed them all. And so now I have to come in here and figure out pairs of being 0. So first two are 0. First and third are 0. First and last are 0. Okay, that takes care of all the first. I could have the second and the third 0. The second and the last 0. You see how I'm exhausting all the possibilities as I go down. And finally, the last possibility is the last two are 0. So we go step by step. First two are 0. That means all of this junk is 0. S1 and S2 are 7 and 12. All right, so now X1, S1 are 0. All right, so this is 0, this is 0, X2 is 7, and I can plug that in to figure out S2. Similarly, I can come in here and pick X1, 0, and S2, 0. So I'm going down each of the possibilities and then figuring out what the remainder are. All right, x2 and x2 is 0 and s1 is 0. That's these two. And finally, if the last two are 0, then I get a system of equations to solve. So I'm going to try to eliminate x1, multiplying through by -1, and figuring out what x1 and x2 are. Now, what about the feasible business? All right, so F for feasible, everything is positive. Here's something not greater than or equal to 0, so that's not feasible. Similarly here, not feasible. So anytime any of your pieces are not 0 or positive, meaning that they're negative, it's not feasible. All right, so here on question 10, they want us to graph it and look at the picture. All right, so we have x1 plus x2 equals 6. There's one of my lines. Let the first one be 0, second one then would be 6. If the second one is 0, first one is 6. So what that gives me is this particular line where it intersects the axes there. On the other one, setting it equal, when the first is 0, the second one is 4. When the second one is 0, first one is 12. So what that gives me is all the corner points. What's missing is where is the intersection of those two. So I have to figure that out by solving this system. Multiply through by -1, add them up, and I figure out that x2 is 3. Well, if x2 is 3, then 3 plus 3 is 6. So this gives me this corner point. Okay, so these are all my feasible areas. All right, so let's see. Looking here at what's feasible and not feasible, we have 0, 0. Oh, this is not feasible because S2 is -6. This is not feasible because it's at minus, it again has a negative. So if you look at all the feasible places, let's see if I can get them on the screen. We have 0, 0, 0, 4, 6, 0, 3, 3. Well, that corresponds to all of the places here on my graph that are actually in the region. You see, these that are not feasible are not in the shaded part. All right, we repeat that same process for problem 11 here. I need to figure out what each of these lines look like, so I play the game of setting different pieces to 0. If x1 is 0, then this has to be a 5. x2 is 0, then I can solve for x1 and get 12.5. So I've got 0, 5, that's this point. 12.5 and 0. Well, luckily they've divided this into 0.5. See, 10, 10.5, 11, 11.5, 12, 12.5. If I do this for the other set, setting pieces to 0, I get 0 and 5.5, which is here, and I get 11, 0. So what I can see from this graph so far is 0, 5.5 is not feasible, 12.50 not feasible. These three are feasible along with the point of intersection. So where do they intersect? So again, I have to solve this system of equations. I'm going to eliminate x1, multiplying through by -2, adding, and I get x2 is 3 and x1 is 5. And so you can see the feasible are the ones we talked about. The not feasible have negative parts in them, and that's why they are not feasible. All right, let's see here. We're given a system. We would like to maximize this. Well, everything is feasible because they're all positive. So let's see what's going on here. Well, here's my graph. Here's my line. Okay, the feasible region is here. Here are all my corner points. So let's make a table and we're going to plug in each of the corner points. All right, this corner point was 0, 10. So 0, 0, P is 0. 0, 10, I get a 70. And at 9, 0, I get 36. So the maximum value is 70, and it's occurring at the point 0, 10. All right, let's see. Question 13. They're giving us this table All right, let's see the not feasible. I've got negative pieces. So here are all the parts that are feasible: 0, 0, 0, 3, 6, 0, and 4, 2. So I simply take each of the points, plug them in, and see what P calculates to be. 0, 0, 0, 0, 3, 72, 6, 0, 96, and 4, 2, 112. That's clearly the biggest number, so that is the maximum value, and it's occurring at the corner point of 4, 2. All right, question 14. Let's see. They give us this table for our system here. Negative pieces, so those are not feasible. So the feasible points are 0, 0, 0, 4, 9, 0, 5, 2. So I make a table and plug them in. So I figure out at 0, 0, P is 0. And at the other points, the values that I get. The biggest number is 198, and that is occurring at the point 9, 0. And that concludes section 6.1.